In this segment of building the EMG6, we have a universal tip that you should find useful for more than just building airplanes. This is a tip for treating cable ends to prevent them from unraveling, and a process that we have coined as twist welding. Aircraft use cables to control everything from carburetors to flight controls. One universal problem with any cable is what to do with the cutoff end of the cable. Many times the cable is in an environment where the cable is either being manipulated or removed and reinstalled on a regular basis for maintenance purposes. This generally results in the individual wires within the end of the cable becoming untwisted and frayed. This frayed cable end presents a problem. If you pull the cable through the hole, it may not be possible to gather up all the ends tight enough to actually reinsert them once again. And oftentimes, the frayed end of the cable is so bad, it's not even possible to remove the cable from the outer housing to replace it without cutting off the end. One method for handling this is to twist weld, a term that we've coined to treat the end of the cable to prevent it from becoming frayed in the first place. This method is extremely effective, and I've yet to see a cable treated in this manner become untwisted. This process is very simple and can be done with hand tools that are contained within most everyone's toolbox. All that's required is a slow turning, variable speed cordless drill, a propane torch, and a vise or a pair of pliers. Insert the damaged end of the cable into the cordless drill chuck. Tighten it up, and then hold the other end of the cable 2 to 4 inches away from the drill chuck using either a vise or a pair of pliers. With a propane torch on low heat, apply the flame to the cable. Once the cable begins to turn to an orange color from the flame, it's time to start spinning the cable at a very low speed. Continue to twist the cable while simultaneously heating. As the cable is twisted, it will fuse the cable wires together, forming a solid end. Continue twisting until there's enough stress built up in the cable to separate the cable into 2 pieces. A couple of points that will really improve the outcome of this process. The first trick is to use a cordless drill that turns at a very low speed, let's say somewhere in the neighborhood of 20 to 100 RPM. The second trick is to apply a few pounds of tension onto the cable by pulling the cordless drill during this turning process. This will do 2 things. The first is that it will help maintain a nice straight end after the cable separates. Failure to maintain tension while you're twisting the cable will simply result in the end of the cable taking a slight twist just as it starts to break off. The second thing that applying pressure does is it helps to narrow the diameter of the cable during the twisting process, which will make it much simpler to insert into a hole such as the throttle arm on a Bing carburetor. If we take the cable end where we have applied the twist weld method to it, we can sand down the cross section and reveal the fused nature of each individual wire. The cable ends are literally welded together. Keep in mind that we know this process is affecting the structural integrity of the cable where we have applied the heat to it. This simply means that you should use this process and leave enough additional cable that this is not a factor. In addition to the structural considerations, we need to be aware that the heating of the cable will make the cable more susceptible to corrosion. One way to deal with this is simply dip the end of the cable that you've just twist welded together into a container of paint or primer. An etching primer from a spray can is thin enough that it works well when sprayed into a cup. Make sure that you let it sit for a few minutes so that it can absorb as much of the paint as possible. Then remove the cable from the primer and hang it, letting the drips fall off the end of the cable. This will keep the thickness of the paint on the cable end in the reduced section thin enough that it won't interfere with the insertion into the attachment hole. With our newly developed twist weld cable end, we're now ready to put our cable into service. We hope you've enjoyed this episode of the video series Building the EMG6. Thank you for watching, and remember to like us on our YouTube channel.